Okay, so we got this situation in which we have to find out equation of tangent in point form, parametric form and slope form. You have already handled the same situation in circle, parabola, ellipse, hyperbola, correct? Where we used to use some transformations. We used to call S as the equation of curve, है ना? Then S1 we used to call it as point satisfaction, means we used to satisfy points, and then we used to take t. T is some transformation. Okay, now what are the transformation we used to take? We used to replace x square with x x1. We used to replace y square with y y1, and then we used to replace x with x plus x1 by 2. We used to replace y with y plus y1 by 2, and then we used to replace xy. Xy is replaced by x y1 x1 y by 2, and then we have a constant. So constant is c, so c will be as it is. Okay, so these things you have to take care while handling these results. Now what will happen, they will be giving you a point on the curve, and then they will ask you to write down equation of tangent. So what you will do, you will take t equals to 0, okay, and you will get equation of tangent. Okay, now think about second situation, parametric form. So what you have to do, they will give you a curve x square by a square minus y square by b square equals to 1. So what we will do, we will imagine a point in parametric form. So it is something square minus something square equals to 1. We have one formula, sec square theta minus tan square theta equals to 1. So we will take help of that. So we will take x as a sec theta comma b tan theta. So we got a point on the curve. Now we will put t equals to 0. We will get equation of tangent in parametric form. I hope till this part you guys are okay. Now think about the third situation, when they will give you slope. They will already give you the slope, and then they will ask you to write down equation of tangent. So under those case, how will you respond? So just ignore the slope for time being and follow parametric form. What you will do, take a point on the curve, put t equals to 0. If you will put t equals to 0, you will get equation of tangent. Now you can compare your slope of tangent with given slope of tangent. You will get corresponding perpendicular, base or hypotenuse, and then you can update your equation of tangent. So this way we will handle slope form. Or if you can memorize, like condition for tangency, it was c square equals to a square m square minus b square. You can take help of this equation as well. Otherwise, you know that you will take help of parametric form. I hope till this part you guys are comfortable. Okay, now think about the normal form. Same situation. While dealing with normal, you have to take help of tangents, because like suppose they will give you a point on the curve. So you know how to write down equation of tangent if point on the curve is given. So suppose that you have calculated t equals to 0, equation of tangent, correct? Now do you know that the slope of product of slope of tangent into normal is -1. So can I say that you will get a slope of normal, and you already have a point on the curve. You have a point on the curve. Now you got slope of normal. So don't you think that you can use slope point form to write down equation of straight line and things are done, correct? So this way we will write down equation of normal. Same way in parametric form. Suppose that you have to write down equation of tangent in parametric form. So how will you respond? Step 1, take a point in parametric form on the curve, put t equals to 0, you will get equation of tangent. From equation of tangent you can take help of this result to find out slope of normal. Now you got a slope of normal, you got a point in parametric form. Now use slope point form to write down equation of straight line. Things are done. And same thing you will do with slope form. How? We will take help of parametric form. Parametric form, we'll take a point, then t equals to 0, we got slope of tangent, and then we will take help of this result to write down equation of slope of normal. Done. If you'll get slope of normal, according to you, you can compare that slope of normal with the given slope and you will get corresponding perpendicular base or hypotenuse, and then you can update. You will have more clarity when we will do some illustrations. In upcoming sessions we will be doing those situations. Okay, you will have better clarity, but for time being this is the idea how we will approach these kind of questions. I hope things are clear.